Bonjour à tous. I'm going to do the presentation in English, if you don't mind, in consideration to our various partners. So let's kick in. I'm Heik. I'm the CEO and co-founder of Fireblocks. Before we start, let's make this a little interactive. I want to ask a question. Who in this room feels that they are virtually safe and protected? Raise your hands. Inspiring. So you use VPNs, firewalls, authentication, encryption, and a bunch of other solutions to make yourself safe. And yet it's not the case. So what is missing? Ownership, control, trust. We're going to explore a little bit all of these topics. In the meantime, I'm sure that all of you are familiar with different kinds of cyber attacks, phishing, ransomware. If you're not, you're at the wrong event. But how much are you aware of lateral movement? We're going to dive in. So first of all, in the wise words of the former CEO and chairman of Cisco, there are two types of companies. Those that have been hacked and those that are not aware yet that they have been hacked. In other words, in the words of my favorite pre-Socratic philosopher, Mike Tyson, everybody has a plan until they get punched in the face. The same applies to hacking. Truth is, the reason we don't feel safe is because we aren't. Phishing and ransomware is merely the first step. Once the hacker successfully penetrates the network, then there are 3 simple steps which leads to them unlocking full control access towards your infrastructure. It all starts with recon, which is scanning the network. They map your environment silently. They scan the network, identify machines, services, users. They look for critical data, critical information within Active Directory, databases, backups, it doesn't matter. Unlocking it allows them to take control without you knowing it. Taking control is the second step, acquiring the keys. It's getting access to the credentials, becoming part of the environment without anybody knowing that you are there, which is horrible because the user can become an admin and the admin can take control. And once again, without you fully acknowledging what happened. And then, as soon as you've gained full control, you've got the keys, you're inside the environment, you're a shadow operative because you take control of the infrastructure and you can do whatever you want. And so, we witness these kinds of situations all the time and the consequences are catastrophic. Since we see a 200% increase in ransomware attacks year on year, since every attack is responsible for around $4.5 million in losses per company, and where 70% of ransomware attacks involve lateral movement. So once again, we see this happening all the time, everywhere, all at once. One recent use case that we can illustrate, publicly exposed in December 2025, French Ministry of Interior being compromised because of one single attack through email inboxes, unlocking passwords, getting access to critical data. So the initial breach allowed them to gain access to what they call the CHEOPS, the Central Gateway to Police Systems, and immediately start gaining access to various critical data, notably police records, wanted persons, and obviously using it for ransom later on. This allowed for them to also gain access to multiple sensitive systems and to circulate around the environment for days without being noticed. As a matter of fact, this happens all the time. There is nothing unusual about it because just in the last 6 months, we can bring up a lot of different examples with the 1.2 million bank accounts being breached, with La Poste suffering an attack that they called the worst DDoS attack, the most intense DDoS attack they've ever witnessed. And this goes on with municipalities, with France Travail, and I'm just focusing on France because we're in France. But if we had to expand the list, I can give you a use case, a different use case every day. That is a problem. So, where does this lead us? Let's dive deeper into one of the core problems. In front of you have an example of the metadata of an TCP/IP header. What we notice is that today we're still increasingly relying on standards that have been created for the last 60 years and which compromise us because of one simple fact. As long as an attacker identifies your address space, whether through scanning, whether through leaks, misconfigurations, whatever you call it, they know exactly where to start. So tell me, how are we supposed to feel safe if we are constantly exposed? When the question is not if, but when. And so, it's time to think a little differently. I'm going to challenge you on this a little bit, because I'm going to talk about disruptive solutions when it comes to networks and core network architectures. Let's talk about core network architectures, the core TCP/IP model, and its underlying infrastructure. So, the architecture was conceived about 50 years ago. And then, instead of making rendering architectures modular, adaptive, natively secure, to render them future-proof and to be able to consistently anticipate and act, not adapt post factum, we have created constantly layers and layers, piles and piles of hardware, software, protocol solutions which come and position themselves on top of the core architecture, thus creating vulnerabilities, congestion, complexity, and lack of modularity, which doesn't allow us to quickly adapt to the growing rate of innovation. Everybody loves to talk about AI, but AI is also used to increase the rate of cyber attacks and actually reduce the time of a lateral movement from months to days to minutes. On average today, with AI, you can actually enable lateral movement in 17 minutes, which used to be days. So, what if it could be different? What if it could be more simple? And what if you could actually gain ownership, control over your own infrastructure by actually having your own addresses that are not necessarily conform with any standard, with any IPv4 or IPv6 norm, but present you a non-IP addressing system where you can not only configure your addresses, but the addresses become modular, dynamic, and adaptive, which means they can be updated consistently over a period of time, every week, every month, every year, as per the needs of your critical infrastructures. Well, I'm glad to say that that is exactly what RBlocks delivers. RBlocks went back to the foundation of network architectures, defied the norms of TCP/IP, created a new architectural model combining transport and network layers into a single one, and getting rid of the complexity and congestion by combining all key network features, including authentication, encryption, isolation, VPNs, firewalls, load balancing, you name it, into one single layer. That one single layer is delivered through software. And more importantly, all of these components and key features are natively embedded and entirely configurable, which means that once again, you gain ownership and you can adapt the software according to your needs. Moreover, RBlocks also with native security comes with its non-IP addressing and allowing you to have native security, full flexibility, scalability by design, and uninterrupted availability, since performance is continuous with RBlocks, given the fact that it has a distributed model enabling for every server, every node to continue performing regardless of breaches, regardless of discontinuance. So, coming back to the same model of lateral movement, how does this translate into something applicable, and how does this allow you actually to be fully isolated, protected, and maintain control without being exposed consistently to malicious threats? Step number 1. RBlocks removes the attacker's ability to see the network. There is no topology that is visible because it's obfuscated, meaning that there's nothing to scan. No environment, no maps, nothing. Your addresses are based on non-IP, and they allow for full isolation, meaning that, once again, your topology is fully obfuscated. Step number 2. Enforcing explicit granular communication paths. As you can see, every node is isolated within clusters, which means that RBlocks' native ability to create inherent isolation allows for nodes to be separated, to communicate with one another while maintaining separate clusters. So if for any reason one node is compromised, the rest still remain unreachable because they are bubbled into their own clusters, because they have their own non-IP addresses, and because, step number 3, these addresses are also supported with identity enforcement coming with native authentication and native encryption algorithms, supporting all the more your full interconnect environment. So, keyword, interconnect. I know this sounds a little too daring, sounds sometimes a little bit crazy. We're defying TCP/IP, but the truth is, we are defying TCP/IP, but in no way are we trying to change or replace TCP/IP. RBlocks is a software destined for interconnect environments, coexisting with physical infrastructures, so no changes required on the hardware level, and most importantly, coexisting with TCP/IP. Since it's an interconnect software, it applies on private networks. Public networks continue to rely on standard TCP/IP. More importantly, within the same server, within the interconnect environment, you can have RBlocks and TCP/IP communicating with one another through gateways. What this allows us to do is to have an interconnect software which is hardware agnostic and IP compatible by design, so that there are no radical changes and there are no radical modifications on your infrastructure and within your environment. This is important because the solution is disruptive. It is daring. It relies on years of R&D, but it was very important for us to make sure that the adoption is as simple and clean as possible without bringing any radical disruptions within the way that you deploy it and adopt it. So we essentially rely on OEM partnerships. What we do is we work with existing manufacturers, providers, like Cisco, like Dell, like Thales, like HP, in order to be able to embed our software within their existing material, whether switches, whether high-speed encryptors, servers, you name it, to seamlessly deliver it to end users who benefit from RBlocks' security, efficiency, and modularity without necessarily going through the hassle of configuring it and deploying it within their infrastructure. We essentially work with system integrators, namely actions, in order to be able to ensure these deployments and in order to also ensure replication. So, to share a small use case that we have just finalized recently with our renowned partner, Thales, with their high-speed encryption division, high-speed encryptors are highly effective when it comes to SD1 environments, so public networks. However, given the fact that they still rely on TCP/IP, obviously the LAN environment, the interconnect environment, remains exposed. So we created a complementary joint offer in order to have Thales VHSC protecting user data while RBlocks protects the fabric, enabling full 360-degree protection across both LAN and SD1 environments, so public and private networks. And the first deployments and the first tests have been extremely promising, given the fact that we also benchmarked TCP/IP against R blocks while relying on the same foundation, the virtual high-speed encryptors provided by Thales. And we saw that while with IP, we see that endpoint IP addresses are visible in every frame. Same for ARP network topology remaining visible. Same for endpoint device identifiers being exposed. So if you can see, there's a redundant word that appears next to R blocks, which is not observable. In every case, within the test, we were able to showcase that R blocks brings the necessary level of isolation within Thales's high-speed encryptors. And we're going to continue replicating the same model. We will have further announcements to share soon enough, given our OEM partnerships and given the commercial stage, the commercialization that has been launched ever since this year. So we're happy to share the very first results with you, and we will continue to do so. So, in a nutshell, we invite you to consider alternative models to gain truly full ownership and native security over your systems by applying R blocks. Because simply put, here is why you can find us, and that is exactly why you should contact us. I wanted to leave a little bit of space for questions, but before I do, I also wanted to take the occasion to share another announcement, a piece of information that's important for us. Entering this stage of commercialization also means repositioning ourselves. And as much as we are very attached to R blocks as a name, since it stands for our building blocks, we get tired from going to expos and events and constantly having people telling us, my children love you, because we're constantly compared to Roblox. So we have decided to also move on with a new name. So one more small thing. As of today, we're proud to share that we will be named EONIL, Beyond IP Networks. Thank you very much.
Thank you very much for this presentation. Have you any questions? Est-ce que vous avez des questions? On a du temps, on a 10 minutes. Je laisse un petit peu de suspens. Voilà.
Hi there, thank you very much for the presentation. Technical question on how exactly do you integrate in existing customer environments? Are you doing translation from IP to your address format?
So for technical questions, I'd like to invite Andy, our CTO, if you don't mind, so that he can give you a full-blown answer.
Yeah, thank you so much for the question. So we have two types of deployments with our blocks. It's either directly inside the hosts, which are the servers, through an API, which is kind of similar to the socket APIs in the TCP/IP. So it's direct integration into customer services and etc. And the second deployment option is through what we call an edge gateway deployments, where we don't touch any of the customer services. Rather, we deploy our blocks on the edges of each network segment or let's say a cluster of network devices, and the customer chooses if they want their traffic to be obfuscated through our blocks. They can just forward that traffic through our blocks, and the rest of the traffic can go through either a layer 3 router or directly through a layer 2 switch.
Une autre question?
Thank you.
Voilà,
Thank
merci
you very
en tout
much.
cas. Vous
Merci.
pouvez bien sûr remercier, on peut applaudir avec Manassa Cagnan. Donc merci en tout cas, merci pour cette présentation. Mesdames, Messieurs, dans quelques instants, donc à 11h50, nous avons rendez-vous avec Damien Bancal, fondateur de Zataz. Merci encore. Juste encore pour vous signaler que la sortie, ce sera juste à droite. Merci à vous.